Good afternoon, ladies and gentlemen of Precalculus. Good to see everybody here today. Anyway, in exercise 1 through 4, evaluate the expression without using a calculator. This thing here represents, there is something here we call radical versus rational. Or how would you do this problem mentally without a calculator?
It's not a real number.
It's not a real number?
Yes, it is. It's to the third.
Oh.
To the third, you need negative.
No, it's a cube root.
There we go. That's one.
And what would be how would you explain what a cube root is?
It's a root of a cube. So when you blank a
It's a
cube,
number times itself.
and the roots
three
come to
times.
the ground, that's what they are.
No, it's actually what Kayla said. She said a number times itself 3 times is how you find that. So the answer is, it's the answer to the question, what number multiplied by itself 3 times equals negative 216?
None of them.
7.
Okay, first of all, it's going to be a negative or positive number.
Negative.
It's got to be negative, right?
Actually,
So a negative times a negative times a negative equals negative, right? So we know it's got to be negative. And this is one of the, because the things that you should know, for instance, is you should know your cube root of 8 is equal to,
256.
your cube root of 8 is 2.
Oh.
Okay, cube root of 27 is equal to 3. Okay, so basically it's the same thing, except what if this was negative 8? And that would be negative 2. If this is negative 27, that would be negative 3. So what number times itself 3 times is 216? What is it going to be? Okay, let's continue here. Okay, what is the cube root of negative 64?
4.
It'll be negative 4.
Yeah.
Yes. Okay, well, I'll pick it up later. Okay, we're just kind of following along the theme here. What is the cube root of negative 125? 5. And what is going to be the cube root of negative 216?
6.
Negative 6. Negative 6. And by the way, this is negative 5 here too, right? Yeah, that's it. So what this does is definitely these ones here are ones that you should know, and so you're kind of expanding your mathematical literacy through this a little bit. Okay, so that's going to be our answer to number 1. And let me look at I'm going to spin the wheel for number 2.
I'm only here for number 2. I have it.
Okay, I want somebody to stretch. It could be you, but I know, Kayla, you have it.
The wheel of misfortune.
The wheel of misfortune. The wheel of misfortune. There you go, Angel. That's it. Number 2, Angel. All right. So Angel, on this one, if you have trouble with this one, you know who you could turn to for help, right?
Yeah.
What is this one going to be?
5/2.
5 over 2, okay? Which is your cube root of 125 or cube root of 8. Is that what you got, Kayla, for that?
Yes.
Got that? Yeah. And it says use this without a calculator. One thing that you can really do on this, though, is keep your calculator by the side to check your work, right?
Yep.
All right. Good deal.
Totally.
All right, I'll give you some credit for that here, Angel. I'm going to spin the wheel on number. Okay, this one here. Yeah, this one might be a little more challenging. Do you need me to work this one out? Okay. This one has to do with understanding what radical and rational exponents are. And I've seen in the past we'll have some understanding of that.
Okay.
Okay. So what is this going to be here?
Now, it's gonna be the cube root of 27 squared.
Okay, so Will is saying that this is equal to the cube root of 27, and you say square that, right?
Yeah.
Okay,
Is that right?
well, it's not fully simplified, right?
Right.
So what's going to be the cube root of 27?
3.
So it's equal to 3 squared, which equals 9. Okay, I want to give Will credit for bringing us to this one. And I want to explain briefly about radical exponents and rational exponents. Have you ever heard those before? Well, you can hear about them now. Okay, radical exponents and rational exponents. Okay, radical exponents, like if we have the cube root of 27, that would be example of a radical exponent. And if we have 27 to the 1/3 power, this would be an example of a rational exponent. You are at your level of mathematics, you're getting to the point where a needed skill is to be able to go back and forth between radical and rational exponents. And so basically what you have is this 27 to the 2/3 power is equal to 27 to the 1/3 power squared. And so you can rewrite this 27 to the 1/3 power as the cube root of 27, and that's one that you should be able to do in your head, right? Cube root of 27 is 3, and then 3 squared is 9. So we're going to do some exercise in that later, so that's going to be that one, all right? Actually, I'm just going to leave that right up there. Let's go, okay, the next one here, we're going to pick someone.
Where?
It's going to be Carmen, okay, Carmen.
That means you know how to do it.
Okay, I want you to look back at number 3. And I will tell you something here, that 4 to the 1/2 power is the same as square root of 4, okay? Hint. How's that? So what this is going to be,
Does it just go to 2.5 power or just?
okay, it's going to be the same as 4 square root of 4 to the 5th power. Take attendance. Carmen, you have an answer for us yet? No. Carmen, what if I give you an answer?
Yes.
And then you tell me how we got that answer. The answer's 32. How did we come up with an answer of 32? how do we come up with an answer of 32?
I got 65,000.
You have 65,000, okay. Let's go ahead and look at this. Okay, what is the square root of 4?
2.
2, right?
It's 2 to the 5th power.
So we have 2 to the 5th power.
It's 32.
2, 4, 16 times.
Okay. And what is 2 to the 5th power?
32.
32. And then you can check it in your, you can check this in your calculator too, as, not that you're doing it, 4 to the 502. So you get 4 to the power of 5/2, 32. Okay. All right. Let me put it in the carbon spot. Any questions on that one? Let's go on to the next. Okay, this one right here, I want to introduce or reintroduce you to the laws of exponents. Does this look like something that you're going to be able to do pretty easily here? Kaylee says yes. You know how to do this one, Kaylee? All right, Kaylee, what'd you get for this one?
Is 2 to the negative 3 power negative?
What? Or no?
No.
Mr. Jake, will you come look at mine?
Pardon me?
Will you look at mine real quick?
Okay. Yeah, look at yours.
So, just,
Well, yeah, but it's going to be a lot simpler than that, though. They want to write down the laws of exponents.
I think I got it.
Which is 2.
No. Okay. So we'll do the rules of exponents. We just need to be reintroduced to the rules of exponents. There are 5 major rules of exponents that I can think of. The first one here is called product of power. Well, actually I want power of power. There's power of power. There's product of power. There's a quotient of power. There's the rule of negative exponents. And there are 2 different versions of that. And there's also this last one, the zero power rule, or power of 0 rule.
can you explain each one of those?
Yes. Power of power is if you have x to the power of a, I'm just going to leave a little more room here. If we have x to the power of a, and outside the power of b, it's going to be x to the ab. That is your power of power rule. Okay? Now for product of power, if we have x to the a power times x to the b power, that's going to be what? X to the a plus b. All right? Now for the quotient of power, if we have x to the power of a divided by x to the power of b, we get x to the
A divided by B, A over B.
a minus b.
So,
Okay, the rule of negative exponents is if we have x to the negative a, that's going to be equal to 1 over x to the a power. Or if we have 1 over x to the negative a power, that's going to be equal to x to the a power. And finally, our zero power rule is x to the power of 0 is equal to 1. So those are your 5 major rules of exponents that will really, it's really what you need to know for exponents. Does this in any way, shape, or form look familiar to you?
Yes.
Maybe slightly.
Slightly?
Algebra 1.
Algebra 1? Okay.
I'm been absent that day.
Yeah.
Not
Well,
well, guys, I feel like a whole one.
Well, if you,
Others were home one, but none of us got it.
could be, yeah. Well, what happens is, that's either that or you could have had it really pretty fast. I think in Algebra 2 Honors, my thinking is we probably went over these really quickly once last year. Does anybody remember that from last year?
No.
I don't especially remember it either, so I'm not
It
sure.
is at least.
Yeah, could be, right? Or, anyway, so these look maybe a little familiar. So let's go ahead and apply. I'm just erasing to leave myself room here.
So it's in negative 12 power.
So here, what we have for this one is we're going to have 2 to the negative 12 power, and then using the rules of negative exponents, that's going to be equal to 1 over 2 to the 12th power. So that's going to be our answer. Okay? All right, I'm going to call on somebody for number 6, which is a similar type of problem. And the person I'm calling on for number 6 is going to be we're not going to have either of those people.
Got a bomb.
Okay, what do we have for number 6, Adam?
1 over 3 to the 8th power.
Okay, 4 times negative 2 is negative 8. So you kind of skipped a step there, but that's it, right? Okay. What I want to do is spin the wheel again, get somebody to help us out with number 7, which should be similar. Okay, let's see here. Who's ready? Here it is. So we have Jana. All right, what'd you get from 7 here?
1 over a to the 6th power.
You got 1 over a to the 6th power. Does that look right? Okay, yeah, that's right. And then number 8, I'm going to spin the wheel again for number 8. Okay, number 8. Here we go. I get
She is lucky.
here. there either. It's going to be Will or Kayla. It's going to be Kayla. All right, Kayla.
I got B to the 15th.
So Kayla gets B to the 15th power. Everybody agree with that?
Yep.
Yep, that's going to be right. Okay, good. Now, these last two ones are calculator exercises. So if 1 through 8, they're saying don't use your calculator, and now you're saying use your calculator. And basically, it's understanding the keys for this.
I already have both of them.
You already have both of them?
Give other people a chance to keep their points up in here.
You have your calculator? Does anybody have trouble putting that in the calculator? Danny, you know how to put that in the calculator? Anybody have a question about putting this in the calculator? Well, I'm going to assume that somebody who could have been asking the question is not asking the question. Well, I see you're using your own little calculator there. Okay. 5.37824. Okay, here it is. 5.8. Okay, we go to math, and then we go to 5 and put the 5th root. And then here we're going to put in negative 5.37824. Oh, it's the, is that right?
Can we tell you the answer that we get?
Negative
Or can you send the
5.372. So we get that, okay? And then now on this one here, you should get, I think, is it 3.1?
Wait, hold on. There's only 2 people that need to spin the wheel.
Oh, I need to spin the wheel? Okay, here, let me spin the wheel.
No,
That's what you're
people,
doing.
you need to spin the wheel.
Okay, we're just, what I need to do is I need to eliminate the names here. So we got Will, okay. Yeah, Katie, why don't you give us the answer to the 10?
Okay. It's 3.1.
3.1? And what it is they give it's 3.100 something, but in the book they just call it 3.1. What it is, right? So yeah, so it's really an exercise in just using a calculator.
This is the last one.
Okay, next thing, we're going to work on another assignment today too, which has to do with rules of exponents, with using exponential functions actually. I'll pick that up after class, okay? Now, the first 6 exercises here are in what is or is not an exponential function. Okay. What is or is not an exponential function. And I will explain what you have to have, what is the anatomy of an exponential function. So we come here and we get to this section right here. Okay, so I'll call this, I'm going to put little notes here, I'll call this anatomy of exponential function.
I don't think it's a super user that has anatomy in it.
That's,
Okay, anatomy of an exponential function is if we have y equals a times b to the power of x. And these things here has a is equal to what? Does anybody know what that is? A is called your initial value. And b is going to be your base. And then this x here is going to be your independent variable. So your variable has to be in the place of an exponent to qualify to be an exponential function. So in this case here, for this one right here, I know what I'm going to do for this one. I'm going to do this.
Spin the wheel.
Yeah, I'm going to spin the wheel, but I'm going to do something else to make it more efficient too. I'm going to make my wheel more efficient today. I'm going to do something, it's not a permanent thing. Right? And is everybody else in here? Yes, everybody here, right? Okay, good. So if somebody will answer number one, we're spinning that wheel for number one. It's going to be Jane, all right? Okay, Jana, exponential function or not? Yes or no?
I don't know.
She says you don't know, okay? Okay, Jana will have it anyway, but I'm going to try to give her leading questions. Okay, this x right here, it's y equals x to the power of 8. Is this x a base? Right? Is that a base? And your 8 is your power, right? So these things right here, initial value and base must be numbers. But this place of the exponent is not a number. It is x. So is this an example of an exponential function? No, it is not. No. And it says why not? Well, because you need a variable as the exponent, right? So variable needed as exponent. If I could spell variable, that would be nice. Okay, so that's going to be number one. And now for number two, I'm going to spin that wheel for number two. Here's number two. It'll be hello, room 15. Okay, she'll be right with you very momentarily.
Okay, let's say,
Yes, it is an exponential function.
Okay, very good. We'll take it up from there. Just keep your paper with you. Good job. And I owe you two. Here's Caleb.
Here's this paper.
Oh yeah, give me the other paper.
Meet you halfway, Mr. G.
All right, very good, thanks. And then this is your sticker. Very good. And I'll talk about y in a second, she's right about that.
I'll keep it.
And she didn't put her name on that, did she? Oh, well, I'll figure it out.
You don't get lost.
Okay. Okay, this one right here, this could be written as 1 times 3 to the power of x, and so our answer is yes, of course. And what is the initial value? So initial value,
Could you just write A equals 1?
equals 1. Well, not really, because it's not really, it may not be universally known notation that A means initial value. So I'd say not. So initial value equals 1, and then what is the base? Base is equal to
Trace.
3. Okay, and what this looks like when you graph a function like this is your initial value is right here, and it is really the y-intercept. And so you go ahead and the thing will look like this, and where x equals 1, we're going to have y is equal to 3. So this is the point 1 comma 3. And this is 0 comma 1. And what's this point here at negative 1 going to be? Okay, it's going to be negative 1 comma 1/3. Okay? And then if you go to negative 2, that's going to be 1/9. Okay? And so forth. So that's really what it looks like. Okay, next. We're calling somebody for this one. Angel, we're going to get you for Angel. Right?
Yeah,
So he says yes,
yeah,
and initial value.
1. The base is 5.
Okay, questions on that one? Okay. I'm going to spin again for number 4. And
Yeah.
okay, all right.
We're gonna get one of these.
What do you think? No. And for those that are not, why not? There's really no variable anywhere, right? So I'll say no variable is exponent. But it's even worse than that. It doesn't have a variable at all, does it?
Doesn't have much variability.
Yes. And what do we call it? A function without a variable, like this one. What kind of function do we call that?
Linear?
Yeah, it's linear would be like 3x. What do we call that? We talked about it when we talked about the rules of functions. I mean the parent functions. Can we call it a constant function? Constant. What's that? Okay, and number 5. We would have Adam. Okay, 5. Yes or no?
Yes.
Yes, he says. This base here, X, is that a number? Is that a number or a variable?
Variable.
Variable. So the answer in this case is no. Okay, base is not a number. And I'm not 100% sure. I think actually this would qualify because that would be x to the 1/2. So you'd have like this x would be 5x to the 1/2 power. I think that would qualify as a kind of weird exponential function. Okay, next 6. We will pick this one here. Okay, we have Will or Carmen. Who's going to be Will or Carmen? Will or Carmen? Will or Carmen? It's going to be Will.
Carmen, you're out.
Well, then it's just.
Okay, Will, what's this one going to be? No.
You can say it will into existence.
And why not?
Both because the base is not a number, not a constant, and then the independent variable is not a variable.
Not is not exponent, right?
I mean, not exponent.
And this one here is part of what we didn't cover in chapter 2. This is what's called a power function. Okay, so it's possible to have that. Okay, great. I got you for that. Now we're going to go through the next set here, which has to do with evaluating the functions. We may not get to 11 and 12. Well, we should get to the rest of the outside of 11 and 12. And okay, it says compute the exact value of the function for a given x value without using a calculator. And so what would you get for this one right here?
3
Okay, we get f of 0
equals 3.
equals 3 times 5 to the 0 power, and 5 to the 0 power is 1, so that's 3. So that was without a calculator? Man, that's like super genius. All right. Next, I will spin the wheel on this guy here. This has a little more level of complexity.
I wonder who's going to be.
Carmen, no, do I need to spin the wheel for Carmen?
Yes.
Spoon.
All right.
It's gonna run on that.
Okay, Carmen's going to be doing this.
What happens if you remove the last name? What does it do?
Okay, let's see what happens when I remove Carmen. See what happens. Blank wheel. All right, Carmen, what do you got for this one? Okay. No. Look at your rules of exponents, right? What are you going to do with using rules of exponents? What are you going to do with this thing here? Rule of negative exponents. So it's going to be 6 times, that's times by the way, 6 times 1 over 3 squared equals 6/9, which further simplifies to Okay? Is that pretty simple? Okay. Let's see what 9 and 10 are. Yeah, we'll get that. So, let's see, we need to have a new wheel spinning here.
Spin it again.
No, I don't think it'll do anything. So we're just going to have to start over again. Adam, all right.
Wow.
Yeah.
Wow.
All right, Adam. What'd you get for this one? Okay. Equals?
I'm not quite done.
Oh. Okay. Really running short on class time. So 3 to the 1/3 power is the same as cube root of 3, right? So this one right here would be -2 times cube root of 3. So that's as far as we could go without a calculator, in my view. And then this last one here, I'll just go over that one real quickly. So we have f of -3/2 is equal to 8 times 4 to the -3/2, which is the same as 8 times 1 over 4 to the 3/2. And 4 to the 3/2 is equal to square root of 2 to the 3rd power. So that's going to be equal to 8 times 1 over square root of 4 to the 3rd power, which is going to be 8 times 1, square root of 4 is 2, 2 cubed is 8. And so our answer for this is going to be 1.
Can you go back to, can you go back to,
To 9?
yes.
Okay, here's 9 right here. So we're just going to have to leave it there today and come back to 10 and 11 tomorrow with a fresh brain, all right? So if you can hand in what you've done so far.